Hello everyone, today we are going to discuss the fifth problem of AtCoder beginner contest 313, which is duplicate. So we are given a string S containing digits from 1 to 9. We have to perform some kind of operations to S, which is explained here, and at the end we have to find that the total number of operations takes to make the length of the string S to 1. So let me go to the operations, what the operations are. So what is the operation? Let's say our current string is 313. So what we will do, we will go to I from 1 to length of s minus 1. Let's say length of s is n. Now when we are at some index, let's say I, we will take k equals to s of I plus 1. So let's say we are at index 0, s of I plus 1 will be 1. Okay, so we will take another new string t, which is empty at the start, and we will loop through from 0 to length of s minus 1, and we will try to append this si k number of times. Okay, so initially s of I is 3 and s of I plus 1 equals to k is 1, so we will append k one time. Now we are at index 1, and si plus 1 is 3, so k will be 3, so we will append si 3 times, so 3 1 1 1. Now let's go to this. So now si is 3 and si plus 1 is 1, so we will append 3 here, and we are at si plus 1 is s1, which is 1, and si plus 1 is 1, so we will append 1, and similarly it will be 3 1 1, and after that it will be 3 1, and at the end it will be 3. So total number of operations taken is operation 1, operation 2, operation 3, and here from this to this is operation 4. So total number of operation here is 4, so our answer will be 4. So uh, this is the first example, and I have explained you this thing. Okay, now there is another case. If you will repeat the operation indefinitely or infinite number of times, our answer will be minus 1. So let's say we are doing this operation again and again, and the length of s never becomes 1, then our answer will be minus 1. So this case is quite straightforward, so that's why we will try to explain this case first. So our first observation will be this minus 1 case. So let's say we have some substring, two length substring x y, where both x comma y greater than 1. Okay, I hope you got it. Now when we are performing some operation, we'll have this x y number of times. So x will be repeated y number of times, and y will be repeated uh, k number of times. Y k is the digit next to y. So let's take for this case the digit next to y is 1. So y will be repeated only once. So now here you can see in this substring there is some substring of length 2, which is xx. Okay, we have some string xx. So now in every operation you perform on this string, this substring xx will be repeated again every time, so this will be loop. So what I am trying to say, if there is some substring xy in the string, then for every operation after that, xx substring will be there. So the length of the substring, length of the string will never become 1. It will be at least 2. Okay. So that's why if there are two characters which are not 1 are adjacent in the string, our answer will be minus 1. So that's explained in my code here. What I am doing here is that if ai is not equals to 1 and ai plus 1 is not equals to 1, then now I am making the flag equals to 1 and breaking from the loop. So if our flag is 1, that means two adjacent characters which are not 1, then our answer will be minus 1. Okay, I hope you got it. That is the only case where answer is not possible. So now let's jump into the other cases first. Okay, so what are the other cases? For other cases, we will have some other observation here. So the other observation is that, let's say we have some non-1 characters, let's say x, y in the substring, and let's say s is something like x1, y1, z1, like that. So if two non-1 characters can't be adjacent, then our string will be in this form x1, y1, z1, like that. So in fs also we will have x1 some number of times, y1 some number of times, z1 some number of times. Okay, so what I am trying to say, I am trying to say that every character which is not 1 will come same number of time in S and Fs. So let's say there are k number of non one characters in S, then there will be k number of non one characters in f of S, f of 2 of S, f3s, f4s. Okay, so that is the first observation. So what is the second observation? Second observation is that if we look from the right character, right end to the left end, let's say we have something like 2 1 3 1 3. Okay, let's say we have something like 2 1 3 1 3. Now we are looping from the in right end to the left end. Now we are deleting the character. We will be first deleting 3, because you have observed here now that the last character is getting deleted every time. Okay, first three got deleted, then this one got deleted, then this one got deleted. So only we are deleting from the right end, and the number of times this one appears is dependent on the number of deletions happened at the right end of it. Okay, so here you can see that 3 got deleted, so we have 3 ones. Okay, so I will try to explain through this case 2131c. So we have 21313. So after the first operation it will become 2, and this one will come 3 number of times, 1 2 3. Now it will be 3 1 1 1. Okay, so now this one have occurred 3 number of times. Let's say this is the first operation. Now this will be the second operation. In the second operation, this two will come 1, this one will come once, this one will come once, and this one will come 3 number of times. Okay, 1 2 3, and the rest of the thing is similar to this, so it will be 3 1 1. And in the next operation, the third operation, this 4 1 will come one time, so it will be 2 1 1 1, and this one will come 3 times, and 3 1. And in the next operation, fourth operation, these 6 ones, 2 3 4 5 6 will come one time, 5 6, and this one will come 3 times. Okay, and it will be 3. I hope you got it. The last characters are getting deleted. So what thing you are observing here is that in each operation, the let's say we have 3 ones here, we have, let's say, k ones here, and in the sorry, we have 3 ones here. In the next operation we are getting added 3 minus 1 number of ones. Okay, so in the next operation there are 5 ones, in the next operation there will be 7 ones. Okay, so what we are happening here, in each operation we are getting ai plus 1 minus 1 number of ones. So let's say we are at index I and del I plus 1 operations have already done, then we'll be having ai plus 1 minus 1 into del I plus 1 number of ones. Okay, so let's jump into the code now. Here what I am doing here, c is nothing but the number of ones. Okay, the number of this character, so 3141. So we will be finding the number of this character. So I have already told that for other non-one characters, these characters will appear only once. So the number, because ai plus 1 will be 1, so the total number of appearance of this one will be nothing but ai plus 1 minus 1, which is 3 minus 1, into answer. Answer is nothing but deletion of I plus 1. So this is nothing but deletion of I plus 1. Okay, ai plus 1 minus 1 into deletion of I plus 1, plus this character will get deleted, so we are adding plus 1 here, and we are adding this plus c to the answer. And at the end we have deleted every character, but we have to make the length of the string 1, and now the length of the string is 0, so we will be deleting minus 1. Okay, I hope you got it. Let me explain this thing once again. So let's say we are deletion of I plus 1 is nothing but the total number of deletion happened till I plus 1 index. Okay, I hope you got it. Let's delete this. Deletion of I means the total number of deletion operations taken to delete till index I from the right side. Okay, I hope you got it. Now when we are deleting some index I have already told this is the formula, ai plus 1 minus 1 into deletion of I plus 1 will be the number of ones. Okay, I hope you got it. So this is nothing but deletion of I, and at the end we have to add everything to the answer. So answer is nothing but del I plus 1, like that. I hope you got it. Please like the video and subscribe to the channel, and